Hi there, my name is Cecil Phillip and I'm a cloud developer advocate here at Microsoft. And in this session, we're going to talk about growing serverless with Azure Functions and C#. The main goal of this talk is going to be really to understand what is this serverless thing and how's it going to help me build better software. Also, we're going to take a look at Azure Functions and see how we could build, test, and deploy serverless applications using some of the tooling that's available in Visual Studio today. Now, the first thing I want to do is, I want to start off with talking about how the cloud platform has evolved over this period of time. Now, this might be familiar to a lot of you already, but I think it's important that we understand how these services have become much richer and also been able to handle a lot more for us. So let's start off with talking about what happened before the cloud. Now, before the cloud, I had to manage my own infrastructure. That means that I had to think about hardware. I had to worry about disks and backups. I had to worry about doing operating system updates. And this generated a lot of work for our IT staff. When you think about developers, we had to worry about, well, what does it actually take to deploy our application into this environment? After that, when the cloud was introduced, we were introduced to IaaS, or Infrastructure as a Service. So what that means now is that instead of having to manage the hardware ourselves, cloud providers like Microsoft Azure would do that for us. So what we would do is we'd go in and we'd create a virtual machine, and we'd still be responsible for the operating system updates, we'll still be responsible for taking care and provisioning the software we need, but I don't have to worry about the hardware anymore. I don't have to worry about disks and backups and a lot of those things that it really take up a lot of time. After that, we were introduced to PaaS, or Platform as a Service. Now, this took us another step forward in the way that we build applications in the cloud. With PaaS, essentially, I can just say, hey, I need some compute power to run my application on. And I don't want to manage the server, I don't want to manage the hardware, I just want to be able to write my code and deploy it to the cloud. With PaaS, we also have the ability to scale our applications by setting certain types of thresholds. So maybe I want to say, hey, it's Christmas, and I'm expecting a lot of people to come over to my website. I might want to say, whenever that date hits, I want you to scale up my application a little bit. And then after that, I want you to scale it back down. And this made it a lot easier for developers to build applications. Actually, I could tell you a story. I remember a few years ago when I first started working, and to get a virtual machine or to get an environment set up just to test my application, it used to be like 2 weeks of conversation. I can't imagine taking that long just to try out my application in an environment. But now with things like Platform as a Service, I can do that much quicker. But the thing with that now is that even though we have this really rich service that's able to do this for us, I still need to think about things like scale. I still need to think about the server. I still need to say, hey, could you please give me some compute power, and this is how much memory I want, and this is how much hard drive space I want. And this is where serverless computing makes it a lot easier for us. So what is this serverless thing exactly? When we think about serverless, that name might throw you off a little bit, but think about it this way. Serverless makes you think less about the servers that you're putting your machines on, that you're putting your code on. So I don't have to worry about hardware or software, or I don't have to think about any of that type of stuff. Think about this like your wireless router you have at home. Now, your wireless router does have wires. It is plugged into something. But from your perspective, from the person that's consuming it, I don't need to worry about those wires. All I need to worry about is, hey, can I get connectivity from this device? And we should think about serverless in a very similar way. With serverless applications, I don't think about the software, I don't think about the hardware at all. I just think about, I have code and there's somewhere that I could send my code that it could run, and it'll scale automatically, and I don't have to worry about any of that other stuff. And that abstraction of servers is a really powerful thing, and one of the key factors that makes serverless the next step in the evolution of how we're building applications in the cloud today. Now, another key facet of serverless is the fact that it's event-driven. Now, if I write some code and it's running in a serverless environment, it's not actually doing anything until I say, hey, it's time for you to run. So my code is effectively sitting dormant until some trigger fires off and lets it know it's time for it to go to work. So, as an example, I might have a trigger like an HTTP call, or I might have a trigger like something like I've added a file to blob storage. And then my code will listen for those particular triggers, and then it'll fire off and it'll get going. Now, this actually introduces a really interesting dynamic with the way that we get billed for these services. So again, if you think about IaaS, and I'm setting up a virtual machine, the entire time that virtual machine is running, I have to be paying for that machine. So I have to think about, wait, am I really utilizing this machine to its full potential? Even the same thing too when we're talking about platform as a service. I still need to think about, well, how am I actually going to scale these things? With serverless applications, I don't have to think about that at all. The platform should automatically figure that out for me. And that actually alleviates me from thinking about infrastructure, and all I have to think about now is deploying my code and getting it into where it needs to be. So let's talk about some other benefits of serverless. So again, we talked about automatic scale. When I deploy my app into a serverless environment, the framework automatically knows, based on the load and the amount of requests that are coming in, how I need to scale up or down. Also, too, it allows me to just focus primarily on my business logic. Now, I might be working for a company that might be into medical, or maybe I'm into education, or maybe I'm in a company that sells insurance. I'm not in the business of managing infrastructure. I'm in the business of solving business problems. And those are the things I want to focus on. Not how much hard drive space I need or how many backups I need. But I want to be able to solve problems that are going to help my business move forward and help us turn a profit. Another great thing about serverless is because we're writing these really tight and really focused pieces of code, it allows us to get to the market a lot faster. And we're going to see what that looks like as we get into the demos pretty soon. Now, in Microsoft Azure, we have 3 core components that make up our serverless offering. First, we have Azure Functions, which essentially is going to be our serverless compute. And that's going to be the main focus of our talk today. And we're going to get to that a little bit later. We also have Logic Apps. Logic Apps essentially allows us to visually design a workflow. And another really cool thing about Logic Apps is that it has so many interesting connectors to it. So for instance, I might have my Logic app orchestrating a collection of different Azure functions, and then it'll allow me to integrate things like SendGrid for sending out emails or Twilio for sending out text messages. Now the last piece we have, and probably the newest service in the bunch, is called Azure Event Grid. Event Grid is essentially a message routing service, which allows us to publish events to various parts of Azure. Now, if you think about it, essentially I'll have subscribers on one side that's listening for various different events, and I'll have publishers on the other side that are publishing the events that my subscribers are interested in. One of the really cool things that I like about Azure Event Grid is the fact that it's really built into the DNA of Azure. So I can have built-in events such as, hey, let me know when a new subscription was added to my account, or let me know when a new web service was added. Let me know when a new database or somebody decided to insert a record into my database. Also, too, I can also publish my own custom events. So any way that you want to do it, we can have a really powerful way to orchestrate all of these serverless compute with functions, logic apps, and also Event Grid. Now, let's get to the star of the show. Let's talk about Azure Functions. Azure Functions essentially is the merger of code and events. Again, when we talk about serverless, my code essentially is just running in this platform, and it's waiting for somebody to say, hey, it's time for you to run. And the way Azure Functions allows us to do this is by having these things called triggers and bindings. So with triggers, I have different ways that I can let my function know that it's time for you to run. So for instance, I might have a trigger that's based on a schedule. I may also have a trigger that's based on an HTTP call. I may have triggers based on things like blob storage or events that are firing off of Event Grid or Event Hub. Another cool thing about Azure Functions is that it allows us to have these bindings, these input-output bindings, which are essentially the inputs and outputs to our function. So my input could be that item that was put into blob storage. And now I can essentially work with it in a very native way. And all I really need to think about is, well, how do I actually want to handle that inside of my code? I don't really need to think too much about the SDKs that are available or anything like that. Now, let's take a quick look at a demo. I want to show you how easy it is to actually create an Azure function inside of the portal. So I'm going to go to my Azure portal. And I actually already created a function. Now, here, I haven't created any functions inside of here. My function app essentially is just going to be a collection of different Azure functions that I'm going to have. So what I'm going to do is I'm going to go by the Functions tab here, and I'm going to hit Create New Function. And what you're seeing here is that I have a few pre-built options that are available for me. So I can create a webhook, I can create a timer, or I can even create a data processing pipeline. So I can determine the type of function I want to create, and I can also select the type of language I want to use. And I think this is a really important point for us to realize, is that functions really is for everybody. So regardless of what I'm doing, C# or JavaScript, or in the future I can imagine there's tons of other languages that are going to be available here too. So since this is a C# talk, I'm going to select C#, and I'm going to select create this function. And now what's going to happen now is that I'm going to have this function that's going to be created for us. Now, what you're looking at here is a CSX file. Essentially, that's a C# script file. So what you'll see is there's no class inside of it, there's no namespace, it's just my functions and my usings. And I can come inside of the editor here and I can edit the code, and whatever I needed to do, I can handle it right here. So again, that's just how easy it is for me to go ahead and create my function. Now, on the right-hand side, you'll notice we have this test tab. Right inside of here, I can quickly test out this function that was just created for me. So if I hit this run button here on the right side, you notice the function will fire off. I'll give it a second or two. And then eventually, it'll come back and it'll show me my responses back. Tick, 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 tick. There we go. Now, I'm going to expand the bottom here. What you're seeing here is the live logs that are coming up, and it's letting me know what's happening inside of my function. And then also at the bottom right, you can notice here, we could see the output. So again, we have a really nice experience here about how we can create functions inside of the portal. Now, this was an HTTP trigger function. Let's create another one. I'm going to hit the add button again. And again, notice here that we have the option of creating a lot of different types of languages, but I'm going to stick with C#. Now, as of today, right now, C#, JavaScript, and I believe also F# are the main supported languages. And some of these other ones are in here, they're just experimental support. So they're not completely ready, but we'd really love for you to come and tell us, well, what do you think about them, and give us some feedback. Anyway, so I'm going to select the language C#, I'm going to hit trigger. And now as I come down to the bottom, notice that I can give my function a name. Oh, sorry. I'm going to give this function a name. And I'm just going to call this DNC trigger, right? And now, under the schedule section, what we're seeing here is that we could specify the schedule in a cron drop type fashion. So right now, it's set up to run every 5 minutes. I want to change this, so this is going to run every, let's say every 3 seconds. I don't think you guys want to wait every 5 minutes for a function. I'm put a */3. I'm going to hit create, and now, there we go. Now my function is actually created for me. Now it's not running yet, but before I start it to run, let's actually add some more code to it, because it's really not doing too much here. So what I'm going to do is I'm going to go to our HTTP trigger function. Let me save this really quick. And what I want to do is I'm going to hit get function URL. And now I'm going to hit copy. And now going back to my trigger function, what I want to do is actually going to have my trigger call my HTTP function every 3 seconds. So I'm going to say var client is equal to new HTTP client. And then inside my HTTP client, I'm going to say client.get async. I'm going to pass it in, that's the location of our function. I'm going to give it a query string parameter. I'm going to just call this Cecil really quick. Right. Now I want to await this. So I'm going to say var response is equal to await. And then the next thing that I'm going to do is I'm going to say var content. I'm going to grab the content out of this. Await, I'm going to say response.content.read as string async. There you go. So again, I'm just using the HTTP client to grab this information from us. And now because I'm using await in my function, I need to mark my function as async. So I'm going to put this async thing here at the top. Now that we have that going, what I'm going to do here instead is I just want to log out my content. So I'm going to take out this code that was created for us before, and I'm just going to say content. So what I'm expecting to happen now is that every 3 seconds, this is going to call my function that I created, and then it should print out that content out into the logs. So let's hit save and run and see what happens. Let's close this. It was saved. Function is started. And then if I zoom into the logs here a little bit so you guys can see it, notice that every 3 seconds this is firing off and this is saying, hey Cecil. So again, it's calling, this trigger is firing off every 3 seconds and it's calling the function that we created before. Now, let's go ahead and see what else we could do with our functions. If I go into this HTTP trigger section, I can go into manage, for instance. And I can look at things like, here's some of the function keys that I have available. So these keys are particularly for my HTTP trigger functions. And this will allow me to add like some level of security in it. It's kind of like me adding API keys. Also too, I can hit this monitor tab. Inside of this monitor tab, I can get some basic information about how and when my function is being called. So we're gonna just give it a few seconds. And you'll notice here, these are all the calls that are being made, right? And again, these are all coming from that trigger that we created a little while ago. And those is kind of just going. All right, great. Now, let's go back to the slides really quickly. So that was an example of how we could create functions inside of the portal. And there's a lot of cool tooling that's inside of there. But one thing I want to tell you about me is that, well, I'm more of a Visual Studio guy. I live and breathe in Visual Studio all day. You know, I love the tooling, I love IntelliSense, I love the power to be able to debug my applications on my computer. And so because of that, we actually have the option to do that with Visual Studio 2017. If you have 15.3 and you make sure that you install the Azure workload, you'll be able to build and test your applications locally using some tooling that's really available to you. And I'm going to show you that in a second. Now, if we take a look at this, we can see what creating a function would look like if we did inside of Visual Studio. And one really interesting thing about it is that you'll notice we're using attributes here to specify the triggers and also the bindings. So here, if you notice, my first attribute is letting me know what's the name of my function that I'm creating. Then I have queues and a queue trigger that's going to say, hey, anytime I put something in the queue, I want you to fire off this function. And then I also have input and output bindings. So here I have a blob storage input, and I also have a document DB mode. So this will allow me to work with these data stores. And notice too that I'm not thinking too much about the blob storage API or even the document DB API. I could just focus on writing my code, and then the runtime for Azure Functions is going to handle a lot of that for me. So let's head over to Visual Studio and see what it looks like to debug and test my applications locally using Azure Functions. So I have an application that we created. And actually, before I show you the code, why don't I show you what the app looks like? So let's go back to Chrome really quickly. And so what I'm going to show you is a simple to-do app that we made. The front end is essentially to-do MVC, and there's various implementations built with Angular, with React, and a lot of different JavaScript frameworks. But all of them are being backed by Azure Functions. So if I hit this React sample, for instance, it's going to load my web application, and we're going to see what the front of it looks like. And here you can see I have a simple to-do list that I created. So I want to make sure that after the session is done, that I check my hurricane shutters, I get some sleep. I also want to make sure that I eat something. That's really important that we do that. And I can come in here and I could mark things as completed. I could delete to-dos, or I can even add a new to-do. Watch .NET conf sessions. All right. So now I've added that on my list of things to do. Now let's go back and take a look and see what the actual code that built this looks like inside of Azure Functions. So here I have a very simple function app that I already created in Visual Studio. And I have a few functions that are in here. And let's move this to the side so we can have a little bit of space so we can see what's happening. So here you can see I have a few functions that I have. So there's a get all to-dos function that's inside here. There's one that'll get a single to-do. I have create to-dos. And there's also delete to-dos and update to-dos. So pretty much I'm doing CRUD using Azure Functions. Now here's something interesting that I want you to pay attention to. If we take a look at this HTTP trigger, you can see that I'm specifying certain values to this attribute. So for instance, here I'm saying I want my authorization level to be anonymous. So what this will allow me to do is say, well, anybody can call my HTTP endpoint. You might want to do something different, and you might want to use the API key that we saw in the portal to specify what level of access that people have. Also, the next parameter is allowing me to say what HTTP methods that I could use. So right now I'm just using get, but you can also specify put, post, delete, and any other valid option. Also, what's interesting here is that you notice that I have a route property. The route property is going to allow me to say, this is the endpoint that's going to be associated with this particular function. So here, if I make a GET request to API/todos, then it should trigger this function and it should start running for me. Another interesting thing that we could do is we can also specify route templates. So if we look at this get to-do one, now this is a little bit different because this is going to get me a single to-do. So what I might want to do is I might want to specify the ID of that item that I want to get back. So inside of my HTTP trigger function, again, similar to what we were doing before, I'm specifying my authorization level, I'm specifying the HTTP method, but in the route, notice that in brackets I have the ID. And that's allowing me to say, whatever value is going to get put on the end of that URL, that's going to essentially be the ID for my item that I want to get back. And so how exactly would we get this ID? So essentially what I'm doing here on line 59 is you see that I'll specify a variable, in this case it's going to be a string of type ID, and notice that that name matches the name that's inside of the route. So the Azure Functions runtime is smart enough to know that it needs to match whatever that value is in the route and inject that into my function using that name. All right, so let's run this and see what it looks like to actually build this on my machine. So I'm gonna hit the run button. And now what you're seeing here is the Azure Functions runtime is getting started up on my machine. This is not any different from the one that's running in Azure. This is not a simulator or something that's kind of faking the experience. This is the same runtime running here locally on your machine. Now that it's up and running, you see here, it's actually showing us all the different functions that we have available. So notice I have my create to do, deletes, get alls, and so on. Now, how I want to test this function, I'm going to use a tool called Postman. Now, Postman is a really interesting HTTP testing tool. It allows me to specify things like the endpoint I want to use. I can specify whether I want to send GET or POST requests, for instance. I can specify custom headers and things like that. I really like it too because it keeps a history of all the requests that I've made before in the past, and you can see that on the left side. So let's make a call to my function. So here I'm making a call to localhost 7071/API/todos. So I'm going to hit send. Oh, that's not good. I'm going to hit send, and I should have some to-dos in here. Let's go back and see what's going on. Let's scroll up a little bit. I'm going to put my breakpoint here. Let's see what's going on. So let's send this over again. And notice now it's hitting my breakpoint. And I'm going to step over these items. And again, using the tooling inside of Visual Studio, I can come and look and see what's happening here. So notice as it's making this query, I'm not getting anything back. So I'm going to stop debugging this right now. And I'm going to head over to my actual functions project. Now, one thing that we have locally is this thing called localsettings.json. And with local settings, this essentially is where we can do things like set environment variables and so on for my Azure Functions. So notice here I have some environment variables set up, such as my table, and also I have this thing called application insights instrumentation key. And that's going to be used for application insights, and we'll talk about that a little bit later. Now, my table here essentially should have that connection information to my table storage account that has all of my to-dos inside of it. And so if I'm looking around here, notice that here it's set to my to-dos, right? And so this essentially is going to be my input binding for my table. So let's head back to the portal and see how I could get that information back. So I'm going to go to, I actually have this running already. So I'm going to click here. And one of the things that I could do is, when I click on my function, I can go to application settings. And inside of the application settings, I can see a lot of those environment variables that I was talking about. So I'm going to come down here. And notice I have this value here, my table. So that's the same value that I was using locally. So let's copy this and see what happens. We're going to Control A that. We're going to go back to Visual Studio. And now I'm going to set that same value that I had set up in Azure to this value that's here. Boom. I'm going to replace that there. All right, let's build this and run this. Builds, let's run it. All right, great. So my runtime is set up, my Azure Functions are running. And now let's go ahead and send a GET request over to my function. So I'm going to send this GET request. There you go, my debugger is kicked in again. And, oh, there's still nothing in there. That's interesting. I wonder where that's happened. Anyway, let's keep going. So essentially what you can see is I have a full debugging experience right here locally on my machine with my Azure Functions. Another thing that we could do is we could test our functions. So at the bottom here, I have a very simple unit testing project. If I open this, what you'll see is that I'm using XUnit. Now, XUnit is a popular using testing framework that a lot of you might be familiar with. So here what you'll see is that I'm also using mock to mock out some of those dependencies that my function is going to take in. I'm creating an HTTP request message. And then I'm also kind of just going through and setting up the function to get tested. Now, every time I build my function, the Test Explorer in Visual Studio should discover those functions and should discover those tests that I have. So notice here on the left side, all of the tests that I've written have already been discovered. So I could right-click, they're already passing, but I could right-click and I could run any of these to make sure that everything is still going. Let's break one of these tests just to make sure that everything is still okay. And that you guys believe me that my tests are actually working. So I'm going to go ahead and right-click and run this. And now what's happening is that Visual Studio is going through and is discovering these tests, it's running them in XUnit. And now on the left side, I should see whether my functions are passing or not. Now notice how I've gotten that red bar. So now it's letting me know that, okay, well, my function is, my tests aren't running. I need to do something to fix this. So I'm going to undo that change that I made. I'm going to save it. And now I should be able to get all green when I'm running my functions. Now, instead of me doing that manually, one of the things that we could rely on is the live unit testing support that we have in Visual Studio. So under the Test tab, I could go to Live Unit Testing. I can hit the Start button. And what you'll see is that it's going to start up that live unit, that live testing runtime. And notice I have all of these check marks that are here. If I head back over to my function, you'll see I have those same green check marks too. So that means that everything is working. Oh, but I also have these dashes here. Well, what does that mean? Covered by 0 test. So essentially what's happening here is that I've only written tests for one function. All these other functions here are not covered at all. So the live unit testing is letting me know that I need to finish writing tests for some of these. So there you go. I can stop this now since we're seeing how that's going. So I'm going to come back in and just turn that off really quick. I can stop it. And so essentially, that's how we could build and test applications running locally using our tooling that's inside of Visual Studio. Now, one other thing I wanted to show you that's really interesting about our functions. You might have noticed that I have this file here called proxies.json. Let's open this really quick. Now, because I'm making this application as a functions API in the background and some static assets in the front, I need to be able to serve my static assets from somewhere. Now, I might not want to necessarily create an entire app service instance or something like that. Instead, what I could do is I could use proxies and I could pass that over to a CDN or wherever my application decides it wants to host these static assets. So if we take a look at this file, you'll notice that I have a proxy condition set to /API. And then I'm sending this over to my website host. And then you'll also see that I also have some other routes set up, and these are going to different implementations of that to-do application inside of my app. And if I open my solution really quickly, you'll see I have all those assets inside of this www folder. So I have implementations for Angular, jQuery, plain old JavaScript, and even React. So essentially what's happening here is I'm using proxies to send it over to blob storage. I have all of my assets, my CSS, my static HTML, my JavaScript, all inside of blob storage. And now I can just use proxies to say, hey, I want you to go there to get these things and come back. Now when you deploy your app, you actually get a proxies tab inside of your function. So if I come here, and we notice the proxies tab here on the left side, these are the various proxies that I created. And then you can see exactly what the proxy URL is, and you can also see where it's actually sending it to. And then you can also specify things like request overrides and response overrides if you want to override the HTTP headers. And I think this allows a very powerful use case for if you want to build simple single-page applications using a very serverless type model. Marcelo, let me ask you some questions real quick. Any plans and time frame for VB.NET support? That's a good question, Marcelo. So we're definitely looking at VB.NET support, but I'm not totally sure when that's going to happen. But if there's any particular use case you'd like to see it in, let us know. You can put an issue on GitHub or just send us a message on Twitter. All right, so that's our proxies. Now let's head back over to to PowerPoint. There we go. So we've seen how we could build, test, and do all of this work locally with our Azure Functions. But we need a little bit more than that, right? Like I need to be able to deploy this too. I want to be able to run a CI/CD pipeline, right? And so we can easily do this with VSTS. I'm going to show you how we did that really quickly. And also, after our functions are deployed, we need to be able to monitor them too. So we have a really cool service called Application Insights that's going to allow us to do that. So I could track things like custom metrics. I can track things like the request time and various other telemetry that comes out of my Azure Functions app. So let's go ahead and take a look and see how we could build and deploy using some tooling that's inside of Visual Studio. So I'm going to head back over to Visual Studio. And what I'm going to do is I'm just going to go to my function. And inside of Team Explorer, I actually have some changes I needed to commit. So here, I already created some changes. I'm going to call this generate debug symbols. And I'm going to hit commit, staged, and push. So what this is going to do is this is going to send these requests, this is going to send these changes over to my GitHub repo that this application is stored in right now. And now what I'm going to do is I'm going to come over to my VSTS dashboard. Now what's really cool about this is that I can get right up front some really interesting information about what's happening with that code I just deployed. So here you can see on the left side I have my build history, I can see how my tests have been running, and then I also can see a list of the different releases that we've done so far. Now I'm going to hit build and release, and then go to builds. And then now on the left side, I'm going to see my build definitions. So let's click on this and see what's inside of here. So here we should see this latest build is in progress. And let me make that a little bit bigger for you guys. So this latest build is in progress. So this is the change that I just committed just now. I'm going to select this. And what we should see is that we should have a console, and it should let us know exactly what's happening. On the left side, we can see some of the various steps that are going to be going through in our side of our build. So it's going to get our sources, do a NuGet restore, it's going to build our solution, run the unit tests, and then it's also going to create these artifacts that we're going to use to send over to Azure. Now, while that's running, let's go back, and I can show you what the build definition looks like. So on the right side, I'm just going to hit this edit button. And now notice here on the left side, we can see the various steps that are taking place. And one thing I really want to highlight for you guys is that notice that I'm getting this code from GitHub. So what's really cool is that wherever your code lives, we can pull it in and deploy it. And that's a really powerful story here about VSTS. So I have my Azure Functions app, and it's inside of GitHub, inside of a repo. And now it's just going to pull it in, and it's going to run all these various build steps that we created. Okay, we have another question. I have the demo for the to-do app. What is the advantage of using Azure Functions versus just communicating with DocumentDB directly? Sure. So one of the things that you could do, first of all, I generally wouldn't want to just put a database exposed out to the internet like that. I usually don't think that's a good idea. I think we've seen in the past that that's not worked out well for a lot of people. Another thing that I would tell you too is that with Azure Functions, it kind of allows you to offload some of that work in the background. So if you don't necessarily want to do a lot of that work up front, you want to do that outer process, that'll be another reason why you might want to do something like that. All right, let's head back over to releases. So what's happened now is that our build has been successful, and now we've kicked off a release. So what's happening now is that after my build, my tests have passed, my code has been built, what it's going to do now is going to send it over to my release pipeline that's going to provision all of my environments inside of Azure that I need to run this application. So let's take a look at this. So I'm going to hit this release tab, and you can kind of see what's happening here. So my function to do build is on the left side, and on the right side, what I have is my release pipeline. So I'm going to click on this, and we're going to see what's actually happening. So it's going to take those artifacts from my build. It's going to deploy an ARM template. It's going to create an Azure App Service for me. It's going to copy those static assets for me. It's going to put it inside of blob storage. Because remember, that's where all my JavaScript files, my CSS files are all living. And then it's going to go ahead and it's going to create my blob storage and set it to public, because that's really important for it to do. And so once that's all complete, I should have a full application that's up and ready to go, hosted inside of Azure. And so let's actually come back to Visual Studio. Actually, you know what? Let's do this. I want to show you application insights and show you how powerful this thing is. So for my function to do apps, I'm going to select my function app here at the top. I'm going to go to Overview. And notice here at the bottom, I have this thing called Application Insights. Now, this only shows up if you have that option turned on. So I'm going to select this. And now it should take me to the instance of Application Insights that's listening to my information. Here, if I click the live stream, this shows me a really interesting dynamic because it lets me know exactly what's happening right now inside of my Azure function. So if there are any live requests that are going on at this moment, or any failures, I'll be able to see that right here at the bottom. If I had anything that's consuming my CPU, it'll also show me that too. So right now, nobody's using the app. Let's go in here and let's create some to-dos and move them around. I can clear all of these, for instance. I can click around a little bit. Okay. I notice here at the right side, it's showing me if I have errors coming in. It's showing me requests and traces and stuff like that. It's giving me a lot of information about my Azure function that I just set up. Now, I'm going to come out of this. Another thing that we could go to that I think is really cool is going into the analytics section. So what this is going to give us a really powerful query language to get really deep into what's happening inside of our function. So for instance, I have some queries that I already created. So if I click on this one, notice that I'm just specifying, I want you to give me back all of the exceptions that happened inside of my function. So when I hit go, let's move this up here a little bit. When I hit go inside of here, what should happen is that it should churn through all of those records and let me know, hey, here are all the exceptions that we found inside of your function. And so this really gives us a good idea to find out what exactly is happening. So I could go through where I can see, for instance, this was a null reference exception for some reason. And it's happening inside of my create to do app, my create to do function. So I might want to go in there and see exactly what's happening. Now, if I was supposed to run this on my computer, I'm going to go ahead and run this again. And what I'll do is I'm going to open up Postman again, and I want to use Postman to test this out for me. So my create to do function actually accepts a HTTP post. And I'm just going to specify an empty body. And I'm going to send a request over there, and let's see what happens. So I'm sending my request. And now I'm going to hit this breakpoint. Notice when I hover over this to-do, it says to-do is null. And so if I step over this, it's trying to access a property of a null object. So an exception is thrown, And here, using application insights, I'm able to track that exception, and so I can see all of that telemetry and all that information inside of the Azure portal. So let's see if we could fix this really quickly, because I'm not too happy about that exception. So one thing that we could do is we can just check for null here. So we could just say if to-do equals to null. There we go. So that should fix our issue that we're having there. All right, so let's run this again and see if it works locally, and then we can publish it back into Azure. So my function runtime is up. I'm going to hit run here. It should hit my breakpoint in a second. And now as I step through my function, oh, that's not good. Boom. Let's run this again. Let's hit that. To-do is equal to null. Oh, that's what I needed to do. Why didn't you guys tell me that? To-do is not equal to null. All right, that should be a lot better. My function stands up. I'm going to hit run on Postman. It should stop in my debugger really quickly. And now as I step through it, now the rest of my function works just fine. Great, so let's stop this here. Now that I've made this change, I could go ahead and I could publish this over to VSTS, kind of like what we did before. So I'm going to right click. Actually, I'm going to go to Test Explorer. I'm going to go back home, changes, and add null check. I'm going to push this. There you go. And now that that's been pushed, that's going to go ahead and kick off the pipeline like it did before. Now, probably what I really should have done was I should have had some tests that were there ready for this. So again, remember to always unit test your code, because that's going to save you a lot of headache in trying to figure out what exactly is happening inside of your function. All right, we have a quick question from Kumar. Do we support other document DB apart from Cosmos DB? So as of right now, no. But what should be able to happen sometime in the future is that you might be able to specify your own bindings. So if later on, whenever that feature is available, you can specify a binding to whatever database that you want, and you'll be able to work that out for yourself. That was a good question. Thank you. Okay, so let's head back over to the slides really quickly. So here's some resources that will tell you about how you could get involved with Azure Functions. So I guess definitely you can go check it out on docs.microsoft.com. Also, you can check out the Azure Functions website. And then definitely go and check out Try Azure Functions. There's a free trial that you could go in there and just kind of play around with an instance really quickly so you can get a feeling of what it actually feels like. And then also definitely check out their Twitter page. The team is very active on Twitter, and they really like to talk to people and understand what are some of the use cases that you'd like for us to handle. But essentially, we've seen how powerful it is to create these serverless apps inside of Azure Functions. We've seen how we can create triggers, see how we can debug and test locally, and also too how we can publish our service over into Azure. And then we also saw how we could check and see if we're getting exceptions or how our application is doing by taking a look at them through application insights. So I really hope you enjoy Azure Functions. I really hope you try it out. And definitely give us some feedback and let us know what you think about it. Now, we have some more questions that are coming in. Are there any benefits for Azure Functions if I don't have any other Azure services? Sure. I mean, the good thing about Azure Functions is that it's, we can trigger things off of anything. So for instance, if you have an app that's hosted on-premise, and maybe you wanted to just create a little simple function that's going to do some work for you, you can create your Azure function, create an HTTP trigger that'll allow you to access it from anywhere, and then you can go ahead and, whatever code you needed to run, you could go ahead and write it. And again, I think that's going to be really powerful as we start to support more languages going forward. So you don't even necessarily have to be like a C# customer, but maybe you like JavaScript or Python or something else. You should be able to write some code and just have it run. And whatever you needed to do, we should be able to do it for you. Next question. What is the advantage of Azure Functions instead of a virtual machine when Azure Functions seems to be more expensive if a process has to always run? So here's the thing. Serverless is not a solution for everything. Just like PaaS is not a solution for everything. If you remember that slide where we talked about going through the evolution of the cloud platform, there are benefits on each side and there's also trade-offs on each side. You might decide that you want a virtual machine because you want to really hone in and control that hardware. And that's fine. And that might work for you and that's great. For me, if I just have some compute that I might want to offload offline out of my process, or maybe I just have like something really simple I want to set up, and I don't want to create an entire instance. And it only runs once in a while. I don't want to have to pay for it, the whole time. I can just set up a really simple Azure function. It can do for me. But it really depends on your application. Again, serverless is not for everything. PaaS is not for everybody. Infrastructure as a service is not for everybody. You need to really understand, like, what is it exactly that you need to get out of your application? All right, next question. What is the advantage of Azure Functions instead of, we read that one already. Are there any benefits of Azure Functions? Yeah, so we can clear those questions. We answered those already. So again, that should be it. Thank you guys very much. I hope you really enjoyed this session. And again, if you have any more questions or anything like that, definitely feel free to reach out to the Azure Functions team at Azure Functions on Twitter. They're also very active on Stack Overflow. And also send us an issue on GitHub and let us know if you have any particular features that you'd like to see.